Chapter 2, Exercise 1. Assume that A is a set of integers divisible by 4. Similarly, assume that B and C are the sets of integers divisible by 9 and 10, respectively. What is an A intersect B intersect C? This is a very straightforward question. I think it doesn't take too long to solve. And my guess is that it's just to get the reader familiar with what intersections of sets are. So, just as a brief reminder, let's say S and T are sets, as usual. Then S intersect T is equal to the set of all things X, such that X is in S, and Enderton uses the ampersand for and. X is in S and X is in T. Any X that satisfies these two conditions is considered to be inside S intersect T. Okay, so just as a basic high-level understanding of what A intersect B intersect C is, it's going to be the set of all X such that X is in A and X is in B and X is in C. And now the question asks, what is an A intersect B intersect C? So one thing you could answer is, well, it's whatever is in all these three sets. But there's a little bit more nuance to this question, of course, since we get actual descriptions of what is contained in all of these sets. So A specifically contains all integers, divisible by 4. B and C contain all integers divisible by 9 and 10, respectively. So just intuitively or naturally, what we can say is that X is in A intersect B intersect C if it is divisible by 4, 9, and 10. Now, this is another answer. It doesn't quite get to the level of specificity that I would consider good or like an appropriate answer to this question, but we can keep going and ask, okay, what are the numbers divisible by 4, 9, and 10? And this is just a fact from number theory. So X is divisible by 4, 9, and 10 if it is divisible by their least common multiple, which is what this LCM notation is. LCM 4, 9, 10. Now, there's many ways to get to the least common multiple. What I like to do is just decompose each number into factors. So 4 is equal to 2 squared, 9 is equal to 3 squared, and 10 is equal to 2 times 5. And then you list out all the prime numbers that appear in this prime decomposition, or the prime factors of each, and you take their highest power. So here, I'm just going to highlight them with, sure, green number is fine. There's 3 prime numbers, 2, 3, and 5. Note that 2 is here as well. But the highest powers are 2, 2, and implicitly 1. So 2 squared, we have 2 squared, we have 3 squared, and we have 5 to the 1. Thus, LCM 4, 9, 10 is just the product of these 3 numbers times 5, which is equal to 180. All right, so X is divisible not just by 4, 9, and 10, but we can go a step further and say that it's divisible by 180. And since X is just an arbitrary element within this set A intersect B intersect C, then we can say that thus A intersect B intersect C is the set of integers divisible by 180. So to answer Anderson's question, what does an A intersect B intersect C? It is all the integers divisible by 180, all the multiples of 180. And yeah, that's all for this question. I will see you in the next one.